Okay, here we go. This section is all about hypotheses testing. Hypotheses testing for comparing means. The introduction to hypotheses testing. Hypotheses testing, which is decision-making process for evaluating claims about a population. In hypotheses testing, the researcher must define the population under study, state the particular hypotheses that will be investigated, give the significance level, select a sample from the population, collect the data, perform the calculations required for the statistical test, and reach a conclusion. When you learn about research methods, you will notice a little bit more to that just besides the things that are listed here. But because this is statistics, we're only going to look at the following. Now, there are three methods of hypotheses testing. However, I'm going to talk about two. The two methods that we're going to focus on are the traditional method, which is the easier method when doing it by hand. Okay, that's easier, right? And then the p-value method. And the p-value method is the one that you're going to see most often, especially when you're using technology to perform statistical testing. A statistical hypothesis is a conjecture about a population parameter. The conjecture may or may not be true. So basically, a conjecture is a claim. You're making a claim about the population parameter. What a parameter is mu, and mu is the population mean. You're making a claim about a population that could or could not be true. When you are writing hypotheses, there are two types of hypotheses that you must write, and you must state them together. You have the null hypotheses and the alternative hypotheses. The null hypothesis is symbolized by H sub 0, or H naught if you are a mathematical person, but H sub 0. And that is a statistical hypothesis that states that there is no difference between a parameter and a specific value, or there is no difference between two parameters. If there is no difference between something, that means they are the same. And if they are the same, that means it is equal. So when you are writing the null hypothesis and mathematical symbols and a mathematical statement, the null hypothesis will have the equal to sign, the equal to symbol. Just remember that. That is pretty straightforward. The alternative hypothesis, symbolized by H sub 1, is a statistical hypothesis that states the existence of a difference between a parameter and a specific value, or states that there is some sort of difference between two parameters. So a difference must also have a direction that is specified. Or if there's no direction specified, we can go in either direction. To state the hypotheses correctly, a researcher must translate the conjecture or the claim from words into mathematical symbols. The basic symbols that we'll be using are as follows: the equal to sign, the greater than, the not equal to, and the less than. Now remember, for the null hypothesis, there is no difference between a parameter and a specified value. So if there is no difference between a parameter and a specified value, we are going to state, or rather we're going to use the equal to sign. The equal to sign goes with the null hypothesis. For the alternative hypothesis, we'll be using one of these three symbols. And once again, to know which one that you're using, the direction must be specified. Now, here is an issue that I know I'm going to see. Once again, the null hypothesis gets the equals to sign. So if I see anything else for the null hypothesis, and if it's short answer, you will have to lose points. Null states there is no difference. If there is no difference, then it is equal. The alternative is where the difference is specified. And based on the direction that we are focusing on, we will have a direction. If it's one-tailed or two-tailed. If it's right-tailed, left-tailed, or two-tailed. But see, once again, it says the null and alternative hypothesis is stated together, and the null contains the equal sign, as shown. Now, let's say, in this case, we are talking about some sort of increase. When it is an increase, we are using the greater than sign, and that indicates a right tail test because we're looking at the right. If we're talking about some sort of decrease, that is less than. Therefore, that is a left tail test. If we're focusing on some sort of change, but our direction is not specified, that is a two-tailed test. And we're going to use the not equal to sign, indicating that the direction of our change is not being specified. The direction of the difference is not specified. So what we're going to do is here, for number one, we're going to write the null and alternative hypotheses for each of these claims in mathematical symbols. And then we're going to identify the claim. What is the researcher claiming or the investigator claiming? Number one, letter A. A researcher studies gambling in young people. She thinks those who gamble spend more than $30 per day. We want to write the null hypothesis and the alternative hypothesis. Now, for the null hypothesis, if we go back, we're stating that there is no difference between a parameter and a specific value. The parameter, our parameter is mu. If there's no difference, they are equal. So mu is equal to the specific value. And the specific value is $30. So mu equals to $30. Now, the alternative hypothesis states that there is some sort of difference. And if you notice here, it says spend more. Because we are spending more, that is an increase. That is greater than. So for the alternative hypothesis, we are stating that mu is greater than $30. And if you notice, if mu is greater than 30, that is the claim. Because the researcher states that she thinks those who gamble spends more than $30 per day. So that is her claim. And as we can see here, this is a right tail test. Anyways, the answer is this right here. Our null and our alternative hypothesis. B says, a researcher wishes to see if police officer whose spouse work in law enforcement has a lower score on a work stress questionnaire than the average score of 120. Now, the indicator is a lower score. Lower means a decrease. Now, we're going to write our null and our alternative hypothesis. Once again, the null hypothesis states that there is no difference between a parameter and a specified value. Really, no statistically significant difference, but you'll get into that in research methods. So we're going to say that mu, which is our parameter, equals to the specified value of 120. No difference means they're equal. In this case, because it says have a lower score, we're going to write for our alternative hypothesis that mu is less than 120, and that is going to be the claim. That is the researcher's claim. The researcher wishes to see if those who have spouses that work in law enforcement has a lower score on a work stress questionnaire than the average of 120. And this is a left-tailed. For C, it says a researcher feels that if an online textbook is used for the course instead of a hardback book, it may change student scores on the final exam. In the past, the average final exam score for students was 83. Let's write our null and alternative hypothesis. Once again, the null states that there is no difference between a parameter, which is mu, and the specified value, which is going to be 83 in this case. Here, it says that it may change the student's scores on the final exam. The change does not specify the direction. A change can be for the better or for the worse. It can go both ways. Therefore, for my alternative hypothesis, we're going to state that mu is not equal to 83. And that is the claim in this case, because the teacher feels that it may change. That's why we use the not equal to sign, because change can be for the better or for the worse, both directions. And this is a two-tailed test. Now, letter D follow the same sort of steps. The average age of having a first child is 24.5 years. We want to write our null hypothesis and our alternative hypothesis. Once again, the null states that there is no difference between a parameter, which is mu, and the specified value, which is 24.5 years. The alternative states that there is some sort of difference. Now, if you read this question, there is no direction being specified for the difference. Therefore, the difference can go in both directions. So for D, we're going to say that mu does not equal to 24.5 years. However, the claim in this case is going to be the null hypothesis. And the reason why the null hypothesis is the claim, because it says the average age of having your first child is 24.5 years. And the word is means equals. Equals to the age, the average, which is mu, equals 24.5. That's why this is the claim. But moving forward, for the rest of the lectures, the claim will be the alternative hypothesis, because the researcher will be looking for some sort of difference. All right, guys, this is it for the first of 3 videos that comes with the introduction to hypothesis testing. I'll catch you in the next one.